Hello, how's it going? In today's video, we are going to start looking at some post-processing effects. Now, there's definitely a lot more that we can be doing here. This is just a really simple demonstration of how to set up the workflow. So if you've got your own favorite post-processing effects that you'd like to implement, go ahead, knock yourself out. Sounds good. So the core concept that we're working with is that so far we've been rendering 3D things. So we have our models and things and it looks all nice and 3D, but ultimately what that's been doing under the hood is putting things on a texture and putting that texture on the screen. It's been doing it in very elegant ways, but we can basically do that same thing. We can recreate that same thing. I don't know if I'm explaining that well. So when we render everything in our game, we actually have what's called a frame buffer. And a frame buffer is an abstract object which we just render to, and it has various attachments, which are the underlying things that we work with. A render buffer can have one or more color buffers, which are essentially textures, and it has a depth and stencil buffer, which is used for depth testing and stencil testing and things. So what I'm going to do to start with, and I will be going through this explicitly line by line, is I'm going to create a frame buffer, color buffer, and depth buffer. I'll go over to my source code, and in here, my factories. And the texture factory is the one that I'm going to use. There's no particular reason to use one or the other. I just like the texture factory. So to start with, I'll write out my function prototypes. So there we go. Those are our prototypes. Now, the reason I'm passing in the window here is just to be super accurate. I want to get the size of the window that we're working with to make sure that our custom color buffers and depth buffers exactly match the window. When I build the frame buffer, when I build these objects are all unsigned integers, just like everything is, just like a VBO, a VAO, whatever. It returns the created object. Now, on to this part. When I build the frame buffer, I built that frame buffer. Like I said, it's an abstract object. It also needs to have things attached to it. So I'm also going to consume an existing color buffer and depth buffer, attach them to the frame buffer, and then return the created frame buffer. Okay, so now let's grab that and actually fill in those functions. So we'll copy them. We'll go over to the source file, minimize all of this, and we are good to start making our functions. Great, so first of all, we'll just query the size of our window, pass in the pointers to the width and height. They are populated with the appropriate size. Now we'll go ahead and make the color buffer. So ultimately, a color buffer is just a two-dimensional texture, just like any other image. We'll go ahead, generate a texture, set it up ready to work, and we'll now go through and configure the texture. Alright, so those are the configurations, pretty similar to any other texture. I guess the only difference here is we definitely don't want to repeat, especially if we're calculating a value at a pixel by looking at neighboring pixels. If we go off the edge, we don't want to be wrapping around to the other side. But anyway, that's fine. Now, the final step before this is all done is I need to basically allocate width and height pixels. I need to allocate storage for the image. So I'll go through this. So when we allocate storage, we have the target, which of course is texture 2D. The next argument here is a number of levels, number of mipmap levels, of which there will be 1. And then we have the internal format. So I'll go with glRGBA, but this needs to be a sized internal format because we need to know ultimately how many ones and zeros to allocate. Then we have the width and height. Okay, yep, no problem at all. Now, there is a slight difference between this function and something like glText image 2D. Now, my understanding here is that the difference here is that image 2D will create sort of a general, what am I thinking? No, it's a dynamic memory allocation, which gets both allocated and initialized at the same time, if that makes sense. Whereas text storage is a fixed allocation. So what it does is it allocates the memory, but also that memory is fixed. So when we deal with, there's the understanding that the memory allocation is not going to change dynamically on the fly. This makes a bigger difference with something called storage buffers. It's not such a big deal here, but anyway, text storage is good. So what I'll do now is I'll grab this and I'll pretty much start with that in the depth buffer function. Okay, so again, we will, we'll get the width and height of the image. And then instead of generating a texture, I will generate what's called a render buffer. Now, the difference between a render buffer and a texture is that a texture under the hood is actually a texture object plus a sampler object. It does linear sampling, it does all that stuff. A render buffer is just a general, just a general storage thing. It is just the texture with, you can think of it like this, just the texture with no sampler. It's a very simple object with no interpolation or anything, but there is the understanding that a shader should be able to read and write from it. And the reason we have that, of course, is you can interpolate an image and the image looks okay, but if you interpolate a depth information, that is meaningless. It's not true that the pixels next to each other sort of blur their depth. No, pixels have very simple, straightforward shapes. I'm talking too much. Okay, so we've generated the render buffer. What I'm going to do now is bind the render buffer. So I'll go bind, and the target is, why is that not filling in? Yeah, GL render buffer. And now this is a bit of a mouthful, but I need to allocate storage. So I'll go GL render buffer storage. And again, we have the target, and we hover over here, nothing. So I have the target and then the format, and I'll go with GL, depth 24 stencil 8. Side note, you can use 32 bits for your depth buffer. However, if you're not needing all of that accuracy, it does decrease the time. It makes the depth test take longer if we use 32 bits, although it is more accurate. Anyway, so we've got that. Go ahead and return it, and that should be good. And now let's plow on. So we will create a frame buffer and then attach those other objects. Okay, great. So now I'll just go ahead and attach the objects. The first one I'll attach is the color buffer. So I will be attaching a 2D texture to my frame buffer. And now this is a little funky, but let me go for it. So first up we have the target, which is the thing we're attaching to, which is the frame buffer. And then the attachment, and what that is the attachment index. So we'll go GL color, GL color attachment 0. As you can see there, we have multiple textures can be attached to one frame buffer. So if you want to render to a bunch of different textures at the same time, you can do that. Good luck, performance won't be great, but you do have that option. Okay, and then we have the texture target, which in this case is GL texture 2D. And then we have the texture that we're binding, which will be that color buffer. And then finally the level. And again, mipmap level 0 is the level that we're binding. So let's go ahead and do the same thing for the render buffer. So if you look at the notation here, we're going to go GL frame buffer, just like before, because we're attaching something to a frame buffer, and the thing we're attaching is not a texture, but it's a render buffer. Okay, so just the same as before, our texture is there, and then the attachment is not a color buffer, but the depth and stencil. Right, then we have our render buffer target. This gets a little tedious, but of course, the thing we're attaching is a render buffer. There we have, we've specified it. And then finally, the render buffer, which is our depth buffer. Okay, so at this point, again, we have created a frame buffer and we've attached both of the resources that we're going to be using, so we can go ahead and return that frame buffer. Oh, okay, so that was a lot of fun. What I'm going to do now is I'm going to close this down and I'll go to my controller and set that up so that it is... Actually, I changed my mind. Let me do it the other way. If you think of like the controller controls everything, I want to work on the bottom resources and work my way back up. So with that in mind, I'm going to go to my systems and I'm going to look at my render system. So I have my render system. That's the first thing I'm going to work with. And what I want to do, if I go to, here we go. I'm going to say, all right, render system, you are going to also take a handle to a frame buffer. And that's the thing that you're going to draw to. You're not going to draw to the screen. You're going to draw to that frame buffer. So this will just be a little bit of refactoring. I'm going to accept that on my constructor. Then I'm also going to, down here, store it for later use. Right, so then I'll close that down and I'll go to the source code. And of course, you know what's going on here. Right, so then right down in the update function, this is where I go and draw things. What I want to do is, basically I want to draw specifically to that particular frame buffer, not to the screen. And the way I set that as my rendering target is by binding it as the current frame buffer. So I'll go bind frame buffer. I'm going to bind to the GL frame buffer. And the thing I'll be binding is my... This is great, not repetitive at all. Excellent, great. So if I run through this, what all this will basically do is write all that information to that frame color buffer and depth buffer. Now I'm going to get rid of this swap windows, swap buffers, because I don't want to update the screen yet. As a matter of fact, I'm going to head back to my control class, my app, and I'm going to do this. In the app's run function, there we go. In the app's run function, after rendering, I will clear the screen because I'm actually going to have another render system working in here. Alright, so what are we complaining about? I'll fix that up later. Yeah, for sure, I'll fix that up later. I'm just going to go to my shaders. I'm happy with this render system, that's fine. Close that down. Now in the shaders, I'm going to make two new shaders. One of those will be, go vertex post for post processing, and the other one. So for my vertex post, the goal will be to draw a quadrilateral which has the same size as the screen. And we could do that by creating a quad model in our app. Or another way to do it, because this is such a simple task, is just hard code all the values. And that's what I'm going to do. As a matter of fact, I've already done that. So if I go to my sky vertex, grab all of that code, this has positions hard coded to draw a quad on the screen. So let me adjust this. We will not need any uniforms, and we'll be outputting a go fragment text coord. Why can I not spell? There we go. And this is all fine. Okay, cool. So if I add 1 to everything, that'll go now between 0 and 2. So I'll just halve those values. And there we go. Fingers crossed, that'll be fine. So now what I'll do is I will take the sky stuff, so fragment sky, and pretty much duplicate that in fragment post. So we'll take in the texture coordinate, and we will have a sampler 2D called our color buffer. And we're really not going to do anything too fancy. If we do our job correctly, we will see nothing. Sorry, we'll see the same as before. So very exciting. But there we have it. So again, we take the color buffer, which is the texture which was rendered to off screen, and then we sample from that image, and that's what we put on the screen. I know this sounds a little funky, but visualize it as if instead of drawing directly on the screen, you're basically drawing on a piece of fabric which is the same size as the screen. Now what's really cool about that is you can change the image in ways that you wouldn't be able to do if you were rendering it on the fly. So you can do edge filters and things. You can look at the point's neighbors as well. You can put it in black and white. That's what I'll be doing today. But you can also play with the fabric. So you can rustle things around. You can put warping effects on the screen and things like that. Anyway, so having done that, I'll just go over to the systems, and now I'm going to make my post effects system. So I'll just make a new file, and I'll call this my post system. Make my header first, and this is going to be very minimal. Okay, so there we have it. Now something interesting is happening. I wonder if this fixes it. Sometimes it does. If I go Command Palette, delete cache and reconfigure. No, it doesn't fix it. Who cares? It's fine. All right, so basically what we're going to do is this will be a really simple system. It'll just take in a shader, that's my post effects shader, and my color buffer, which is the texture that I rendered to offline, and it'll work with that. So I can go ahead now and create the source file for this. And let me just whip this up real quick. Oh man, just did the funniest typo. Imagine if it was called a color bugger. That'd be hilarious. Okay, so nothing too complex here. What we're doing, this 0 is the value of the default frame buffer. So now when I bind frame buffer 0, anything that I draw is appearing on the screen. Okay, so here I'm setting the screen as my render target. Great. Of course, we're just drawing a two-dimensional quad, so we do not need any depth testing. Now here, yeah, I mean, clear the screen, we don't need to clear the depth buffer, totally fine. Then we get our shader ready to go, just in case we make sure we're on texture unit 0, because I remember the sky was playing around a little bit with texture unit 1. Then we get the texture that we rendered to and set it as our draw source, if that makes sense. And then we just go ahead, draw a raise. Now what I'm doing is I'm not binding any particular mesh because we're actually not going to be using the values, the vertices. It's all hard-coded in the shader. So all we need is an instruction to say execute a draw command, 6 vertices, do your thing. And it overwrites everything. Okay. So hopefully that made sense. Of course, I will need to go down to the CMake lists and include this source file, the postsystem.cpp. So I'll try to get this in alphabetic order. Okay, so at this point everything should be good. And now I'm going to go back to the controller and bring it all together. So I'll just close this down, go to my controller, and then I'll need to include the thing. What am I thinking? The post system. Okay, so down, I've got the post system, that's great. Down here I have unsigned integer being the shaders, and I'm also going to, at this point, declare my things. So I have my frame buffer. Now, I'm actually not using the depth buffer. Like, I'm using it, but I'm not remembering it. I think it's good just to have it anyway. Definitely if we want to prevent memory leaks. Then right down here, we will populate that later. So, that's all good. I'll head over to my source file for my app. Now I'm going to be using the texture factory to make those objects, so I'll make sure to include that. Right. So what I'll do is I will leave this for now. We'll fix it up later. Right down the bottom, set up OpenGL. Okay, so at this point I'm going to need an extra shader. Okay, cool. So that should be good to go. Now right down the bottom, I'll make my other stuff. There we go. That's the workflow that I described. So, all right, that's great. Let me just close this down. And if we want to make something, we'll need to destroy it as well. So what I'll do is I'll just go to the apps destructor and I'll just put this underneath. And why not? Actually, I'll leave that. Okay. Leave that for now. Now we do have an error. We need to pass in the frame buffer. But now that should be fine. And I'm just going to try this. So if this is successful, I should see no errors, but I should also see a completely black screen. Okay, yeah, look, totally fine. Let's have a look at these errors. I think I was just missing a semicolon there. Let's give that a shot. I actually had this error when I was building this for the first time as well. Okay, so very easy thing to miss. Hopefully it's what I'm thinking. So everything is all good. I've just forgotten to scope this to the class. fingers crossed once again. There we go, give it a second. All right, cool. So you can see I have my frame counter up there, so the program is running, but we have a completely black screen, and that's, like I said, because we're rendering to some texture somewhere. Okay, so now what I'll do is I will create a post system for my app and get that image back on the screen. So I'll go to make systems, and now I'll create my post system. And that's just remembering that shader 3 is the one that I want to use. Great. So I'll also go to my destructor and I will delete that post system. Alrighty. So almost there. And now I'll go to the run. And everything should be set up for me. Fingers crossed. So again, I have my render system, and then I will update my post system. And that'll finally blit it to the screen. Okay, let's give it a shot. Excellent. So as you can see, that is back. So again, it's a little subtle, but I rendered to a texture and then I splattered that texture directly onto the screen. Okay. So it would be a bit of a waste if we didn't do at least a little post-processing. Let's jump into the post shader. Jeez, don't do that. This mouse is too sensitive. Okay, so fragment post. What I'll do is I'll just sample this. So I'll go grab the pixel value, then I'll calculate the average of all the components. And then I'll write that back to a pixel. Okay, so again, I just average all the channels and then I splat that out as each of the red, green, blue channels. So if I do my job correctly, this should now be in black and white. So it is. And again, there are heaps of other things we can do. We can take effects where we look at a pixel's neighbors and have some interaction between those in calculating the final pixel value. But yeah, I mean, those are the big things that I wanted to cover. The major topics are the concept of frame buffer, depth buffer, and all of that. Cool. So, as always, I hope you enjoyed this. Hope it's been eye-opening, and I will see you again soon. By the way, there were two videos left in this series for the time being. That was this one, and then the next one will be compute shaders. But after that, I'd like to know, what would you like me to cover? I made a post in my community section of my channel, and the voting on that is being done by likes. So the number of likes, it tallies up. Also in my Discord channel, I have a poll going, which I'm counting as well. Currently, most people are saying they want to see ray tracing, which I sort of agree with. I think that would be super cool. I have some ideas. But yeah, let me know how things are going. And all the best. I'll see you again soon. Bye.